Yeah. Hello, can you hear me? Can you hear me, guys?
Yeah.
So today we continue where we stopped on Tuesday. I introduced the concept of probability. So we just continue from there. So now let us examine some of the basic, I will say re-examine some of the basic rules of probability. Okay. So here, and look at these rules. It says, first one says, the probability of event E is a number. It can be either a fraction, a decimal, or a percent. A number between and including 0 and 1. This is how we write this mathematically. Between and including 0 and 1, which means that the probability of an event can never be negative. Can never have a negative value, or it can never be greater than 1. So if your answer is greater than 1 or have a negative value, that means it's incorrect. Now, this does not apply to answers that are written as a percent. So percent may not is not, it doesn't, this rule doesn't apply to percent. So if your answer is 0.85 and you wrote 85%, you are still good. But you wrote 85 is without the percent symbol. That means the answer is wrong. Because the answer can never be, for probability, can never be bigger than 1 or less than 0. Second rule says, if an event E cannot occur, then its probability is 0. The third one says that if an event E is certain to occur, then its probability is 1. Now, for the fourth one, we're looking at the complementary events. Complementary events, event complement. So I'm going to take you back to that place. Event complement. Now, event complement or complementary events, the best way to put it is this, that the complement of an event E is the set of all outcomes in the sample space that are not included in that event. They're not included in the outcomes of that event. So basically, it's the opposite. Complement means the opposite. For example, the complement of you being in the classroom with me now is you not being in the classroom. The complement of doing an assignment means not doing assignment. So the opposite is the complement. Opposite. Mathematically, we use some mathematical formula to show the complement. I'll show you that in a minute. Okay. So now let us before we can do that, let us do some example, but see how we write the complement for now. Say if event E complement is written as E with a small c at the top. That means E complement. So let's see some do some exercise here. It says find the complement of each event. The first event is selecting a letter of the alphabet and getting a vowel. The complement is not getting a vowel. So, but let's read the question first. Second one says selecting a month of a month and getting a month that begins with J. So let's start with the first one. This one says selecting a letter of the alphabet and getting a vowel. Answer will be for part A will be A. So that means getting any letter that is not a vowel. So they include getting A, B, oh sorry, getting B, C, D, F, G, H, I, okay, I, J, oh, I is a vowel, so I can put I. A, B, C, sorry, B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, and Z. So guessing the consonants. So that's the complement of that. Now the second question says find the complement of selecting a month and getting a month that begins with J. The complement will be the opposite. Getting the month that does not begin with J. So that means for that particular one, the answer will be for B part, getting January. Okay. February. I can't put January because it means getting, it's a getting a month, selecting a month and getting a month that begins with J. So I can't use January. It means February, March, April, May, August, September, October, November, then December, and December. Okay, December. So this is how you do it, and the complement just the opposite. That's the simplest way to describe it. Now we have complementary rules. The probability of E complement is equal to 1 minus probability of E. You can write it in a different way. The probability of E equals 1 minus the probability of E complement. Now let's see how you can apply this in solving questions. Look at this one. But before I do that, does anybody have question in what I have done so far? Okay, no question. Good. Now let's apply this to this. We say in a lottery game, we have in a lottery game, each player chooses a 3-digit number between 000 and 999. A player wins if his or her 3-digit number is chosen. Find the probability that a player buying a single ticket loses in the game. So when you're buying the ticket, you want to win. So the complement of winning is not winning. So in this case, they're asking us to find the probability that a player buying the ticket, a single ticket, loses. That means we are looking for the complement. Okay. First of all, let's find the win. It says that it is a lottery game and the player chooses a 3-digit number between 000 and 999. That means there's 1,000 digits. What are numbers to choose from? So let's use win, W for win, and W lose. We use W complement. We're looking for this probability that the player loses. P complement. P win This W complement equals 1 minus probability of W. Okay, I'm going to make an adjustment now. So we're looking for the probability of W complement. Okay. So you have it right here. That's what we're looking for. So let's find the win. To win out of 1,000, okay, let's find the probability of win. Okay. She bought a single ticket. That means 1 out of 1,000 tickets. That will give us the probability of winning. So you have 1 divided by 1,000 tickets. I'm gonna take you to the calculators where you can do it. You got I think I opened so many pages. Okay, I'm gonna close some of them now. Okay, this is open, so I'm gonna close this. So I wanna go to the calculator. We got 1 divided by 1,000 is 0.001. 0.001. So that the probability of losing becomes that he lose by a single ticket is this. Formula is right here. I'm gonna place it right there. So that the probability of losing probability that the player loses. Player loses in the game is okay. That he loses will be the probability of W complement, which is 1 minus the probability that he wins. Means 1 minus, and we already got that the probability that he wins is 0.001. So 1 minus 0.001, which will give us on the calculator, we have 1 minus 0.001 give us 0.999. 0.999. 0.999. Okay. Or you can call it 99.9% chance that the player loses, which is what we have. Most time, majority of the time, the player loses in a lottery. So if again you find the complement, you find the winning, the probability that the person will win. Now, since we are looking for the complement, you subtract your answer from 1 to get the probability that he loses. Okay. Any question on this? Any question? Excellent, excellent. No question. Good. Now, at this time, we are going to jump into empirical probability. So under this approach, we don't know what the sample space is. But
Excuse me?
Yes, yes, ma'am.
Dr. Oji, are you still recording this session, right?
Yeah, I am.
Do you record the ones in person too, still?
In the classroom?
Yeah.
No, I don't. Only this one.
Oh, okay, thank you.
Welcome. So now somebody just came in. Let's see. So anyway, under this procedure, right? We don't know what the sample space is, so but we estimate it by ourselves by observing the number of occurrences of the event through an experiment and then calculating the required probability from the relative frequency distribution. So the formula we use under this approach is this. The probability of event E equals the frequency of event E divided by the total frequency. So let's apply this to this equation. And then we can go from there. So more says hospital records indicate that the maternity patient stayed in the hospital for the number of days shown below. Okay. It says number of days they stayed, frequency. Those that stayed 3 days have a frequency of 15. Those that stayed 4 days are 32 in number, and so on. So it says find these probabilities that the patient find the following probability that the patient stayed exactly 5 days. B, a patient stayed less than 6 days. C, a patient stayed at most 4 days. D, a patient stayed at least 5 days. We can just make it 4. Make it 4. Okay, so you can see the difference. Well, let's start. First thing to do is to get a sample space by adding all these numbers. Let me write them down so we can go and add them. I got 15 plus 32 plus 56 plus 19 plus 5. Okay, let's go and add it. So we got 15 plus 32 plus 56 plus 19 plus 5. 127. So our sample space or total frequency, let me look at it again. Right, let me look at it and write it down. Is 127. Okay. So our sample space is 127. So I'm going to take you to your class so you can write it down here. So it's the total 127. With that, we can now answer the question. Okay. Now, a patient stayed, if you find this probably that a patient stayed exactly 5 days, right? Part A here. We're looking for that the patient stayed 5 days. Probability that it stayed 5 days exactly. This will be how many people stay 5? This is 5 days. 56 of them stayed 5 days. 56 stayed 5 days. Okay. So we have the probably that person stayed exactly 5 days. 56, since there are 56 that stayed 5 days, it's going to be 56 out of 127. 56 divided by 127. So 56 by 127. 6 divided by 127. 0.441. 0.441 rounded. Okay, 0.441 rounded. Okay. I can call it 4.1% chance that the patient stayed for 5 days. Second one is that the patient stayed less than 6 days. This is 6 days. How many patients stay 6 days? It's 19. But they say less than 6 days. That means you're talking about looking about 5, 3, and 4. Those are the ones that are less than 6 days. So stay less than 6 days. So probability of the state less than 6 days. So you get other probabilities. That's 6 days. So you need probability of 3, 4, and 5, and it will not include 6 because say less than 6 days. 3 plus the probability of 4 plus probability of 5 days, which give us for 3 days. How many stayed 3 days? 15 out of 27, which is 15 over 27 plus for 4 days, you're gonna be 32 over 27 over 32 is 15 over 127, not 27. 15 over 127. 4 days is 32 over 127. 32 over 127 plus for 5 days, you're gonna be 56 over 127. Okay, 56, 127. I'll give you the answer for those that stayed less than 6 days. So I'm gonna write this down. 15 over 127 plus 32 over 127 or 56 over 127. Let's go and put this in the calculator. Fifteen divided by 127 plus, excuse me, plus I got 32 of 127. Yeah, plus 56 for 127. The 0.811. 0.811. So now I'm going to put it right there. Zero 0.811. Excuse me. 0.811. Or I can call it 81.1% chance that the patient stayed less than 6 days. Next one we're looking at is part C, which is a patient stayed at most 4 days. At most 4 days means 4 days or less. Okay. The probability, that's part C. Okay, I see. C, that the probability that they stay at most 4 days equals, like I said, at most 4 days means 4 days or less. So we're looking at probability of 3 and 4. So can be the probability, oh, excuse me, P of 3 plus P of 4, which is equal, for 3, we have 15 over 127. 15 divided by 127 plus for 4, okay, I'll have 32 over 127. 32 by 127. Okay. So that will help you to find the probability of at most 4. Let me write this down and then we can put it on the calculator. Okay. I got 15 over 127 plus 32, 127. Taking you to the calculator, we can simplify this. Oh, I have this already, so I'm going to just clear this side. So that gives us 0.370 rounded. 2.370. I feel like I can just call it at 7%. Okay. Now, next one is a person stayed at least 4 days. At least 4 days. At least 4 days means 4 days or more. So we're looking at 4, 5, 6, and 7. So the patient stayed at least 4 days. So we have D. D. The probability that he stayed at least four days equal the probability of 4 plus the P of 5 plus the P of 6 plus the P of 7. So we can start putting the numbers in. Okay, which is equal for 4, it is 32 over 127. For 5, we have 56 over 127. For 6, 19 over 127. For 7, we got 5 over 127. Let's say at least. That'll give us the results. Okay? Write this down. 32 over 127 plus 56, 127. Plus 19, 127 plus 5 over 127. At most, at least 4 days, 4 days or more. Okay, so we got this. Two over 127 plus 56, 127 plus 19, 127 okay, plus 5. Yeah, 127. 0.881 again. Interesting. 0.8, actually 0.882. Rounded. Yeah, 0. We shall write everything in. Yeah, 6, 5.7. All right, 0.882. 0.882. I can call it 81 or 82, 88.2%. Yeah, chance. That's 8.2% chance that patient stay at least 4 days. So 8.2%. So that's how it's done. Now, at this point, I'll ask again. Does anybody have question on this? Yeah, excellent. Now we can now review some of the more concepts. The first concept we review is what we call mutual exclusiveness. 2 events are A and B are said to be mutually exclusive if they cannot occur together. For example, one cannot be a Democrat and a Republican at the same time. Either you're one, a Democrat, or a Republican. Now, another one is getting a card, getting a 4 and a 6 on a single card. Not possible. They're mutually exclusive. At an intersection, turning left and and then turn right at the same time, they're mutually exclusive. Either if you turn left, that means you can turn right. If you turn right, that means you can turn left. You can't do both of them at the same time. So now we can look at dependent events. Two events are dependent if and only if the occurrence of one event affect the occurrence of the other event in such a way that the probability will change. Okay. So they're dependent if their outcome or the occurrence affect, one event, the occurrence of one event affect the occurrence of the other event in such a way that their joint occurrence, it will affect the probability of their joint occurrence. Okay. So in that one, they say that we have two events, A and B. So if A and B are dependent, it means that the outcome of A affect the outcome of B in such a way that the probability of their occurrence changes. An example, if having good grades is an event and getting a scholarship is another event. So you have good grades, you got scholarship. That's dependent, even example of dependent events. How about this? Parking your car in a no parking zone, if it's an event, and if you're getting a parking ticket, it's an event. So when you park in a no parking zone, you get a parking ticket. Okay. Another one is drawing your eyes. Okay. Anyway, how about this one? Drawing a card from a deck, not replacing it, and then drawing a second card. These are also dependent events because there are 52 cards in a deck. If you remove one card, it's 951 left. So any probability that is calculated but with that 51 card will be affected. I mean, the answer will be affected. Okay. Now, independent events are events that the occurrence of one of them does not in any way affect the occurrence of the other event. For example, drawing a card from a deck and getting a queen, replacing it before drawing the second card. In this case, there are 52 cards. When you remove it, at 51, you replace it for that you still have 52 cards. So the probability calculated with this cannot change. Okay. Another good example is when you win a Maryland lottery. That does not mean that you're gonna win California lottery because you won Maryland lottery. They are not connected. So let's look at the formulas that we use for these rules that we use under these rules. For addition rule, I highly recommend this one. And we know that you're going to use addition rule when it is the question has or A or B. See, A or B equals the probability of A plus the probability of B minus the probability of A and B. I mean, if the event are mutually exclusive, this side will turn to 0. So that's why I recommend it. Okay, now for multiplication rule, we use and as a keyword. For example, the probability of A and B equals to the probability of A times the probability of B. This is for independent events. So if there are 3 events, you keep multiplying. For example, the probability of A and B and C equals to the PA times PB times PC. If there are 4 of them, you keep multiplying. Keyword is or. Okay, now if the if they are dependent events, you use the same formula but with a slight modification. For example, A and B will now becomes the probability that A will occur times the probability that B will occur, given that A have already occurred. Anyway, let's apply this to maybe 2 questions or one. It says, at a political rally, there are 20 Republicans, 13 Democrats, and 6 independents. Okay. If a person is selected at random, find the probability that he or she is either a Democrat or an independent. Now, the keyword there is or that tells you we're going to use the addition rule. And the addition rule says here, okay? I'm going to copy it, okay? Okay, I can just put it right here. Let us use R for the Republicans, D for Democrats, and I for independents. So we're looking for the probability of, you see, Democrat or independent, or independent. So we have Democrat or independent will be probability of D Democrats plus the probability of independent, which is I, minus the probability of Democrats and independent. Oh, I have just put I. When you look at this formula with this one here, the one I just have a few minutes ago, you can see that they're the same. See, A or B equals to probability of A. You can see the probability of Democrats plus the probability of I, which is right here. Okay, this one A or B. This one's A and D or I. Okay. Now, and we can now with this we can now solve the question. Once you break it down like this, we can solve the question. So that we have only Republicans. We have R 20. So we need to get this sample space first. B Democrats. D equals 13. Then independent. I equals independents, 6 independents. So the total will be, which will be a sample space or total frequency. 20 plus 13 is 33 plus 6, 39. So now can I answer the question? So that the probability of getting, this is obviously mutually exclusive because you cannot be a Democrat and independent at the same time. You can either be a Democrat or an independent. Democrats or independent becomes, for Democrat we have 13 out of 39. For independent, we have 6 over 39 minus, yeah. This one will be gonna be D and I in the Democrat independents. Okay. No, there's nobody that is Democrat and independent. That is not possible. So we're gonna put 0 there, 39, which will be okay. Which will be let me see. I'm gonna take it to the calculator. Write this down. Okay. Okay, I have 13 over 39 plus 6 over 39 minus 0 over 39. Let's go there. Get it fast. Okay. I'll check this. 20 plus 13 plus 6, 39. Okay. Let me do the math now. So I got this. 13 divided by 39. Okay. 13 by 39. 13 by 39. Yeah. Plus. Next will be 6 by 39 minus 12, 0 divided by 39. Okay. Okay. Yeah. Let's go to the calculator. Okay. I got 39, 39, 39, 39, then plus that here. 6 over 39. Okay. Minus 0. 9. It was 0.487. Okay. 0.487 or for 8.7% chance that a person is selected at random will be either a Democrat or independent. Okay. Any question on this one? Okay, there's no question. So let's try one more again, one example more, and then we round up. It says a card is drawn from a deck and then replaced. The second card is drawn. Find the probability that of getting a queen and then an ace. So let's use Q for queen, A for ace. And you can see the sample card here. You can see all the aces. There are 4 aces and 4 queens. Anyway, say find the probability of getting a queen and then an ace. The probability. Solution. Excuse me. Have this time around the keyword is and. Okay. That means we're going to use multiplication rule. Now, since this is independent, you select ace does not in any way affect you selecting a queen. So you can just use the multiplication rule for independent events. So we have that the probability of getting a queen, which is Q, and an ace equals the probability of getting a queen. Okay. And the probability of getting an ace. Okay. Which is equal to queen is therefore a number 1, 2, 3, 4. 4 out of 39. Okay, oh, this okay. 252 times for ace, we have 4 aces right here. So 452. And that'll give us the answer we're looking for. So I'm taking it to calculator. We have 4 by 52 times 4 by 52. 0.0059. Answer is 0.0059. Yeah. Any question before we go? Any question? Any question?
Yeah, I have a question. I don't know if you got my email.
Go ahead and ask.
Because I saw that you graded the tennis thing, and I didn't get a full 100, and I haven't missed a class.
Yeah, let's discuss that in class. So I can show you the sign-in sheet. Okay.
Okay.
I can see you then show you the sign, so I know who is talking, and then show you the sign-in sheet. Let's see what happened. Okay.
Mm-hmm. All right. Thank you.
You're welcome. So now let me look at the names of who are here. and change it. Who is Ant? Somebody's name is showing Ant. Who is that person? Okay.
Hello.
Well, are you the Ant? Are you?
Yeah,
What's your full name?
Anthony
Last name?
Paris.
Okay. I didn't see. I didn't see your name. Oh, I see it now. All right, I've checked your name. So let me call your name. If you don't hear your name, let me know. I got this person. I got Jada Betts. I got Sarah Durant. I got Michael. I got Patrick, Christopher, Nevia, Erica, Anthony, Amaya. Okay. Keandra.
What's the name you just said?
What called Amaya? Are you Amaya?
Brenda Patterson?
Yeah.
Here.
So I got Keandra too. Keandra.
Here.
And I got Arijai Robinson. And I got Devin Williams. If you hear your name, you can leave. So if you don't hear your name, if you're here, let me know your name so I can check
Did you
it.
get mentor? Kamaya mentor?
No, I got it now. So you can.
Thank you.
You're welcome.
Did you get Christian Mullen?
I'm getting it now, so you're free to go. Okay. All right. Who else haven't had their names?
Hello, did you say Kai Hairston?
Yeah, I'm looking for that name. Oh, I see it now.
Kai.
Yeah,
Like first
I see
name.
it now.
Thank you.
Welcome.
I'm sorry, did you say Sarah Durant or no?
Yes, I did. Okay. So who else? I'm about to I think I got everybody now. You there, Michael. That's yep, I got it. All right, guys. I will see you on class on Tuesday. Have a nice week.
You too.
Mm.